Okay. No. Come on. Okay. In December 2015, that's 2 years ago, I was working at Wix. I don't work at Wix anymore. And we had an internal hackathon, a week where you can build something for the company, but whatever you want. We decided to replace Wix's aging microservices infrastructure, and we thought we could do it in a week. This is my story. Oh. It will be a movie in 6 parts, actually 7 parts. And we'll see how it goes. Oh, there we go. What about me? I'm Tayar. I'm one of those old guys. I know what a Sickler ZX81 is. I used floppy disks. Carlos is 27 years old. I have 30 years of experience in this industry, but I still love it. I mean, it's changed so much, but I still was, and always will be a software developer. I just love it. I am called an architect because at my age, the ripe old age of 49, you can't be called a software developer. You have to call yourself an architect. And I'm currently working at Applitools. We do visual testing, where you can not only check and test how your application functions like, but also how it looks like. And I'm a huge, huge, huge fan of testing. I test every code I wrote. There we go. So, prologue. Wix. How many of you know Wix? Great. Wix is a company that has a site that helps you build websites. So you can go and build your own website. It's like in a PowerPoint-like way. And there you go, you have a website. They're huge. It's probably old, probably 120 million users by now. 2 billion HTTP requests, 250, 300 microservices, and lots of deployments every day. Carlos was talking about microservices and how you're agile and always deploying. This is how Wix works every day. Unfortunately, there's a very, very old microservices infrastructure. They built it around 2013, something like that. It was top of the line back then. Now it's rusting and aging. First of all, what is a microservices infrastructure from our point of view? And I'm not going to talk about why microservices. We have plenty of talks that discuss that. It's a great architecture. I love it. In the current company I'm working with, I am building using microservices. But what is a microservices infrastructure in this talk? It's code and an infrastructure that helps you deploy your application, your microservices application, helps it run and keeps it healthy so that if one microservice fails, another one pops up. If a server fails, the instance, the microservices are migrated to another server until another one is picked up. So is Wix's infrastructure that bad? It's not bad. It was improved since the time that I was talking about, but the deployments are really, really, really slow. It's chef-based, so you have to wait for that rollout time. It's not very good blue-green deployment. Who knows what blue-green deployment is? Great. Blue-green deployment is when you have version A, version 1, and version 2. And version 1 is in production and you want to deploy version 2. You can't take down all version 1 and then put up version 2. That's not possible. You'll have downtime. So what you do is you put up some version 2s, start dropping other version 2s, put more version 2s, drop version 1s, until finally everything is version 2. That's called blue-green deployment. No idea why. And somebody knows? Okay, see? And very slow rollbacks. In a place where you constantly deploy, rollbacks are critical. Because yes, we test our code, we test it fanatically, but shit happens. And it works on my machine is now translated in, it works in the build system and running our tests. Yes, but production is subtly different. And when you have 100 million users, there's no way you can test what happens at scale. So you have to have rollbacks, and slow rollbacks are really, really bad because customers are impatient. For me, one of the worst things is static definitions. I write microservice A. I know that microservice A is on this server and this server and this server. I know those servers. I know who sits next to me on the same server. And if I need more servers, I pick them up and say, yeah, I also want to be on this server and this server. I was talking to a guy at Wix. He was intimate with his servers. He knew them, really. There's this idea of cattle, not pets. Treat your servers as cattle, as lots and lots of cows, and not as pets, not as your cat. So in Wix, servers are treated as pets, unfortunately. And from my testing fanatic point of view, the way I deploy in production is different than the way I run my end-to-end tests. And it's different from the way I run my code in the staging infrastructure. 3 different environments, 3 different deployment methods. And that's very bad for testing. So, I thought to myself when I started working, can we rebuild it? Can we rebuild a very big infrastructure, and can we do it in a week? And the initial thought was, oh, no way. But then, I thought about God, and he did it, he did it in a week. He built a whole universe in a week. So if God builds a whole universe in a week, we can certainly, just build a microservices infrastructure. So I took a team. I took a team of the best developers out there. Oh, no, not these, sorry, these. That's me over there. This is the head of CD, of DevOps. This is the head of the build system. These 2 are really good friends of mine, top developers. Really, really powerful team. And we started working. We had to have a plan. We started working, we had to have a plan. That was December 15, 2015. First, we needed to define the scope. What is the scope of what we're doing? We're not really going to build everything. That's what we thought initially. And the scope was, we have a web service that a user-facing browser goes to, so it's public-facing, and it uses RPC to talk to another service, which is a more back-end-ish service, which does the work. Okay? So you wanted these 2, and we wanted to be able to deploy these in a fast and nice manner to a microservices infrastructure. And very quickly decided when we want to deploy something, we can use a nice GUI, web app, or we decided let's go with a command line. And that was the best decision we had. Stop writing web apps that deploy. Start writing CLIs. They're very simple to write, especially in Node, but Python is fine, and all those things are fine. And we're back-end people, most of us. So writing a web app is difficult for us. Writing a CLI is like that. So the idea was write the CLI where you can artifact deploy, say what the name of the web service is, what the version is, and how many instances we want of that microservice running. We just write that, press enter, and we get that artifact deployed on our servers. That's what we wanted. And we want to upgrade. We just do a deploy again, but with another version, 1.6. The previous one was 1.5. That was the plan. And we even had marketing. I had my nephew build this and deploy like a boss, because it's built on Mizos. That was our tagline. And we first had to decide what scheduler would we have. Today it's not called a scheduler, it's more called an orchestrator, but they're the same. They're exactly the same. What is a scheduler? Well, this is a server farm. Lots of servers in racks. And these are microservice instances. I have instance A, B, C, D, and E. And I want lots of them. Lots of A's, lots of B's, lots of C's, lots of D's. Because I want to scale up. And the scheduler needs to put these into these. That's what a scheduler does. I tell the scheduler I need 20 A's, 30 B's, 10 C's, whatever, and there we go. It puts them there. And it keeps them healthy. A scheduler always checks the health of a microservice instance, of a microservice, and if it goes down, brings one up. Alternatively, if a server goes down, it redistributes those instances to other servers. With scheduler, we had Mesos Marathon, we had Nomad, we had Mesos Aurora, that's used by Twitter, and Kubernetes. Which one did we choose? We choose Mesos Marathon. Who knows why? Okay, we didn't either, just because. You know, come on, it's a marathon, it's okay, it's a hackathon. And you know, it's a good scheduler, really good. No experience whatsoever before. We had no idea what to do with Mesos Marathon, but we heard it was great. Kubernetes was a bit young back in those days. And then we had to decide on service discovery. And let's talk about service discovery. There are three kinds of service discovery as I define it. One is what I call web service discovery. It's how, when the user writes wix.com/w/whatever, how the service infrastructure knows to go to this web service and not to that web service. There has to be something in the middle that routes it to the correct service. That's one kind of web service discovery. The other kind is the one that most people talk about. I call it RPC service discovery. It's when one web service, one service wants to talk to another service. They don't know where they are. Like A wants to talk to B. There are lots of B's all over. How do I do that? That's RPC service discovery. And last is third-party service discovery, where I have a service, I want to talk to a database, I don't know where that database is. How do I do that? We decided not to do third-party service discovery, and in this talk I'm not going to talk about that. But let's talk about how to implement web service discovery. We decided, well, it's not an incredible solution, we decided on building a gateway. Okay, or a router, as people call it. All the HTTP from the browser will go to that gateway, and it will be a reverse proxy to the web services. That's obvious. What was not obvious was that the rules, which says /w goes to service A and /z goes to service B, were built into the code of that gateway, not in a separate data set. And we rationalized it by saying that configuration is code. So if this is the code of the gateway, its configuration is code. We'll put them in the same source control repository, the code and the production configuration. So that made it much simpler to do. And it's not a bad decision in a way. You want to deploy new rules, you just deploy the gateway again, and you're done. Which proxy? We need to write a reverse. We're not going to write a reverse proxy. That's difficult. Which one? There are two main contenders today. Actually, there are more, Envoy and others. But the main contenders back then were HA proxy, and Nginx. And which one did we decide to go with? Nginx. Anybody know why? Because actually there's a reason we used Nginx at Wix, not HA proxy. But our team didn't know anything about that. We could have used both. And where are the rules? As I said, in source control, in the same repository as the gateway. And how does that gateway know? Okay, it knows to go to service A. How does it know where those servers are? Where those services are? They can be in any one of the machines. And they can listen on any one of the ports. So it doesn't know the IP and it doesn't know the port number. So how? How does it know? The answer, it queries Marathon. We decided to write a gateway that will query Marathon every, 10 seconds, 20 seconds, figure out which web services are where, and reverse proxy. As simple as that. What about RPC? RPC, well, at Wix, RPC is not a REST API. It's a Scala. Wix uses Scala in Java. It's a Scala method call, but that gets translated to HTTP. So service A calls service B, and the way we decided to do that is again a gateway which reverse proxies the HTTP to any one of the services. Same difference, obviously. And which gateway did we use? We know that, Nginx. Where are the rules? Now the rules can't be in the source control because we don't know anything. But remember, this RPC call is translated into HTTP/service A/something. And this call is /service B/something. Our RPC infrastructure at Wix can put the service name in the URL. So if it's in the URL, it's very easy to figure out which service to proxy to. And how does it know where that service is? As usual, it queries Mesos Marathon via gateway. Incredibly similar. That's why both services are usually bundled into one. So let's recap. Let's see how this works from a flow perspective. Our user deploys Apollo deploy service A version X. I need 2 instances. Deploy version B. I need 2 instances. What we do is we ask Marathon, please create service A, please create service B. Use this Docker image. The Docker image is the name of the service, colon the version of the image, and we already have Docker support. We already have Docker support at Wix. And this is and then that's what we tell Marathon. Use this Docker image, deploy it 50 times or 2 times. Marathon deploys it on different servers, deploys 2 versions of B, 2 versions of A. 2 instances of B, 2 instances of A. Now the user goes, our end user, wix.com/apath, to the web gateway. The web gateway knows that apath is service A. How does it know? It's in the source control. Remember, the configuration of the web gateway is in the source control. So it goes and queries Marathon, where is service A? And Marathon tells it it's here and it's here and it's here. It's on this server, on this port, on this server, on this port, etc., etc. And it reverse proxies to service A. Now service A wakes up and calls via RPC service B. This gets translated into an HTTP call, which goes to the RPC gateway. It's always to the RPC gateway. RPC gateway knows that it's service B because it's in the path of the thing. Queries Marathon where service B is and reverse proxies the HTTP. There we go. We have a microservices infrastructure. We just need to build it. That was the plan. So, the job. We split the job. And let's see how we split it. We had 5 jobs. 5 people, 5 jobs. It works. One is the system. How do we write the scripts to deploy Marathon as we want it, both in Vagrant, locally, and to Amazon, to the cloud. The second thing is write a sample web service and RPC service so we can show it out. The third is write the deployment, the CLI command. Fourth is write the gateway for RPC service and write the gateway for web. 5 jobs. Let's start talking about the first. This is where we cheated a bit because the guy, Osela, who wrote the Ansible scripts for that, he's a wizard at Ansible, and he already had something somewhat working he's the guy, he's the one who has 5 servers, in his bedroom so that he can tweak around a bit. So he already had something working, he just needed to tweak it. It worked both on Vagrant, both on locally, and on Amazon. And that is amazing, because I can build a Marathon thing on my local computer and deploy web services on my local computer with the same infrastructure, with the same stuff that I use to deploy to the web, to the cloud. Same thing. Amazing. So he wrote Ansible scripts, and they're almost the same. In Vagrant, there's just one VM, virtual machine, and they need to deploy Mesos and Marathon and Zookeeper and all that stuff. And in Amazon, it's the same thing, except that's on different VMs. The master is on one host, Zookeeper on another host, etc., etc., etc. So we use Ansible for that, but Puppet, Chef, whatever. Sample web service and RPC service. Just regular Wix services. It was important to use regular Wix services that aren't changed because we wanted to show off how existing web services, existing microservices can be deployed. The only thing is we wanted the location of the RPC gateway to be passed as an environment variable so that the microservice shouldn't care. And we'll see later how we pass that environment variable off to the microservice. What about the deployment? That's me. That I was responsible for that. We wanted to write it, and we chose writing it in Node.js because Node.js is wonderful. To install the CLI, it's just one line. npm install -gapollo, that's it. You have the CLI, and it's totally independent of any other thing. Very similar stuff exists in Python, a bit more complicated, but very similar. And just write it down. How does this work? How did the CLI work? Well, it got the name of the service, it got the version of the service, and it got the number of instances. So what did it do? It went to Marathon, and Marathon uses a REST API, a very, very nice REST API, where we give it the app ID. This is the app we want to deploy. So this is the service name of the app. And we just put, HTTP put to Marathon this app ID, this configuration that includes this app ID and everything. How does this configuration look like? This is the configuration, a bit simplified, but basically it says the ID is app ID. This is a Docker container where the image is the service name column version. It's just Docker image. The environment is the RPC gateway will be on the same computer as you in port 9090. And we labeled it as microservices. We'll talk about why later. Health checks, etc., etc. And the important thing is that all the microservices have the same configuration. Again, cattle, not pets. If you're doing microservices and each service has its own, slightly different configuration file for Kubernetes, like for example a YAML file, each one has different YAML files, then you're doing it wrong. You're treating each microservice as pets. We wanted the same one for all microservices. And that's it. We just put it, HTTP put, and Marathon takes care of the rest. Beautifully, beautifully simple. And we talked about that. So let's recap. Marathon, we put it. It sees how many instances needed to be deployed, figures out which servers to deploy and where. That's Mesos. Waits for them to be alive, to go up, and the health check should return okay. And that's it. Now the interesting thing is that the configuration is not a one-off. And we'll see that in a second. So if I put a slightly different configuration, for example, if just the version number is changed, blue-green deployment. Marathon does that automatically. I mean, it's amazing. We could see it. It has this nice GUI, and we can see tuck, 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 the whole thing just switching. In 20 seconds, we demoed it to the VP R&D, and he says, okay, how many services do you want? 50, thanks. How many services do you want? Boom, 30 services, 20 seconds, they were deployed. 40 services, 30 seconds, they were deployed. Amazingly fast. Okay, so we did the 3. What about the last 2? The gateways, the service gateway, the RPC service gateway, and the web service gateway. Oh, sorry, we did that in 3 days. But what about the rest? Problem. We had the head of our infrastructure and the head of our build system in our team. Never do that. Never do that in a hackathon. Because in a hackathon, everybody is not busy, except for those guys. So they had to work, and we had to wait on them. And we had 3 more days with nothing to do. Everything worked, or at least on our end, except for those gateways, which without them, we don't have anything. So we said, okay, let's do something more. We did third-party service discovery, which I will not talk about. What else did we do? And this is important. We did staging. And how do we do that? Our idea was production is just another environment. On the same cluster of hosts, I can have different environments. Production and staging and Gil and Carlos. Everyone has their own environment on the same cluster. How do we do that? We color the microservices with the environment name. So we have A's that are yellow, A's that are blue, and it's not color, it's A that is in production, the A's that are in production, the A's that are in staging, etc., etc., the A's that are in Gil's environment, etc., etc. We changed the CLI to have another -E or --env for the environment. You specify the environment. From the browser, the idea was that there will be a subdomain which specifies what environment you want to go to. And the web service discovery will know that if I'm in an environment stage, I need to service discover only the microservice instances that are in environment stage. So we're basically namespacing everything into one environment. So if the web service discovery works and the RPC discovery works, then we can do that. And now the code in the web service doesn't care. They get an environment variable. They don't care about which environment they are in. This environment variable will tell the RPC service gateway, I'm in environment A, I'm in environment B, etc., etc. As said, we're not talking about third-party service discovery. So it all starts to come together. The head of infrastructure and the head of our build system came back and built the gateways. They did it. How does it work? We have Marathon, we have Nginx. Nginx, how does Nginx work? It has a conf file, which tells it the rules how to reverse proxy. And we have the manager, which is code that generates the Nginx conf. So every 10 seconds or whatever, it queries Marathon, please give me the instances for all the microservice instances. How does it know? Remember, we labeled them as microservices, and we labeled the service name. So when querying, it can query only the microservices and know what their service name is. And then what it does, it rewrites the it doesn't rewrite, it writes the Nginx conf, writes it to disk, and restarts Nginx. Thank you. And restarts Nginx. Now, it doesn't really restart Nginx. There's this switch where you can say, please restart, but don't really, never lose anything. And there's I think it's a sig something. You send it a signal, and it restarts without losing downtime, rereads the nginx-conf, and we're done. And this will be true for both web service discovery and RPC service discovery. It's the same thing. Which language? Bash or Node.js? Incredibly enough, the DevOps guy chose Bash, obviously, and the other guy chose Node.js. Two separate implementations for what is essentially the same code. Bash is easier. Yeah, I'm not sure about that, but okay. Do you? Oh, no, don't. Do you want to start Siri? Okay. So this is the Bash code, somewhat. It's a curling. Where's curl? Curling marathon, querying all the microservices instances and getting a huge JSON. And there's this JQ which can take things from JSON, know what environments there are, for loop on the environments. Remember, stage, production, etc. For each environment, for loop on the apps, on the services. And for each service, use Bash stuff. I'm not a Bash person. To generate the nginx-conf. That's it. Very, very simple. And the generation of the nginx-conf is from a template, obviously. That took another 3 days. Staging, third-party service discovery, CLI, etc., etc. So let's recap. Apollo deploy. The user writes Apollo deploy. It goes to Marathon. Our CLI posts a configuration in JSON to Marathon, which says what the number of instances is, where the RPC gateway is, environment variable, and which Docker image to use. Marathon generates the microservices instances on the servers. Now comes the gateways. Now the gateways, every 10 seconds, query Marathon, figure out which services there are and on which environment they're running, and generate an nginx-conf. Now comes the user. Goes to stage.wix.com/apath. The nginx already is configured for that, so it immediately reverse proxies to A. A calls B via RPC, gets to the RPC gateway. The RPC gateway knows what the instance is, which instance to go to, and knows what the environment is. It already has the nginx-conf for that. Immediately RPCs to B. And there we have it. 6 days, microservices infrastructure, no monitoring, sorry. We didn't write tests. Okay, 6 days. We won the hackathon. I got this nice speaker, Bose. We definitely won the competition. The end result was a microservices infrastructure with a blue-green deployment, not red-green, sorry. Third-party services, staging environments, as many as we want, same infrastructure, built in 6 days. And on the 7th day, what did we do? We rested. We're Jewish, aren't we? So, I knew I had a bit more time. Usually it's less time. How much time do I have? 5 minutes, great. I wanted to talk, because usually, I finish with this and I have my notes. It's a good way to end, but I wanted to discuss what happened, because usually the first question I get after the "we're Jewish, aren't we?" is, okay, so did they use this in production? And the answer is obviously, no, they didn't. Priorities, blah, 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 but they really wanted to. So, no, it never got released at Wix, never. I don't think it still hasn't. The good news is now I'm working at Applet Tools, and I get to write the infrastructure. So yes, I wrote it, and it took me 3 days with tests. I test my microservices infrastructure. There we go. How? How do I do in 3 days what took 5 people to do 7 days? Thank you. So remember what the work was? system work Ansible scripts, sample services, deployment via CLI, RPC service discovery, web service discovery. I didn't need to do all these. Neither this, nor this, this, or this. The only thing I needed to write was deployment via CLI. How? Kubernetes. Kubernetes has become the de facto standard today. Lots of announcements around that. And beautiful, beautiful architecture. It just has everything you need. System. Let's talk about Ansible scripts. You don't need them. If you want to deploy locally, there's Minikube. Minikube is a local deployment of Kubernetes on your non-Windows machine. I think it doesn't work on Windows. So just Minikube install or whatever, and there you go. You have Kubernetes on your machine. What about on the cloud? On the cloud, you have managed services. Google Cloud has managed Kubernetes. Azure just announced managed Kubernetes, and there are rumors that Amazon, in like a week or two, will announce managed Kubernetes. So no need to install Kubernetes anymore on the cloud. So this is taken care of by Kubernetes. What about the sample web service and RPC service? I don't need that. I already wrote my own code. I don't need samples. I use my real web services. What about deployment via CLI? I changed Apollo to K-deploy. I'm getting older and more boring. K is obviously Kubernetes. If somebody has a nice name for that, please come up and tell me. But it's exactly the same parameters. Exactly. What about service discovery? Well, Marathon doesn't have service discovery, but Kubernetes does, and it's built into Kubernetes. RPC service discovery, built into Kubernetes. It's what is called the service thingy. And web service discovery, built into Kubernetes. It's called Ingress for some reason. So I just need to configure them, and we're done. That's it. So Kubernetes saves a huge amount of time. I'm guessing that Marathon has similar stuff. I chose Kubernetes. You know why I chose Kubernetes, right? Well, because, and it's becoming a standard. So it's actually even easier today than it was 2 years ago. Don't be frightened. It's not that difficult building something that, you can deploy to your heart's, developers can deploy to their heart's content any microservice they want, whenever they want. Just do it, and if you need any help, feel free to Twitter me, and thank you very much. Thank you.
Do you have any questions?
Hello.
Hi.
Thank you for the presentation. It was wonderful. I have two questions for you.
Two.
One is fairly obvious. I imagine. Why have you decided to split your infrastructure into web and RPC services? Probably obvious, but just go over.
Well, theoretically, you can put them in one, but that's a monolith in a way. In a way, it's a monolith, but that's fine. That's fine. If you want one big application, it's not really microservices. You want lots and lots of services in the back end, lots and lots of services in the front end, and everybody talking to everybody. It doesn't really matter what architecture you want. I like the whole idea of two.
Is it maybe because of the security reasons?
No, not really. I mean, in the end, both the web and the backend, the RPC, both are behind the firewall. What is in front is Azure or Amazon load balancers. So they're in the same security. So it's not security reasons. I was never a rational guy. I developed from the heart in a way. I don't know, but it just makes sense.
Okay. And the second question is, why are you not talking about why are you not talking about third-party services?
Of the what?
Third-party services.
Oh, you can talk to me about that offline. I'd love to discuss it. It's an interesting thing. it was just because of time. Yes.
You mentioned you designated 3 types of service discovery.
Uh-huh.
By URL, as an RPC, and the third one was the database. But you elaborated a little bit about this. What about the third kind of service?
Third-party service discovery, I just didn't have enough time to do that. Feel free to talk to me offline. But in the end, when I want to talk to a database, that database isn't installed as a Docker image on Kubernetes. It's installed in different ways somewhere, and I have an IP. And the only thing I needed to do was to define where that service is, what the IP and port is, and transmit that information to all the service instances via environment variables. The kink was that if it's a production environment, I know where the MySQL is. But if it's a staging environment, I do want to build a MySQL Docker image, which is used by the Docker image. So our infrastructure knew how to do that, to deal it differently in staging and in production. So that's on one foot.
Yeah, thank you.
Sure. Any more? Great. Thank you very much.
One more.
Oh.
Sorry. And do you compare Kubernetes with recent versions of Swarm? I thought that it's more or less the same, becoming the same. What do you think about it?
Docker Swarm is wonderful because it enables you to just Docker run and just have a huge cluster of machines. But what it doesn't give you is exactly those things that Marathon. It doesn't give you service discovery, weather web, or all that. And I wanted a solution that is whole. And in the end, when Docker, well, let's not go into politics now. but that's the reason.
This is coffee break now.
Thank you very much.